Okay guys, welcome to this video. In the previous video we looked at dynamic and static strings, and basically we are still looking at strings, and we are doing this because strings are very powerful structures or data structures that we use almost in every single piece of method. Like, they are so ubiquitous. It's hard to write your code without manipulating strings. From user inputs to API calls, you're manipulating strings. So in this video today, we want to look at the structure of strings. Basically, we want to look at how strings are implemented and what is close to them. So we are saying that strings in C++ are arrays. Like if you're coming from like C++, you know that strings in C++ they behave like arrays, but in Rust they behave like vectors. The implementations are the same as of vectors in Rust, and that's why we can perform these operations on strings in Rust, such as remove, insert, pop, and that. And so to foment that idea of string implementation, we want to look at some of the basic code and the basic way of manipulating strings. If we have a mutable string s1 that equals to an empty string, of course this is dynamic, that's why we are using the .toString, and we want to push something to s1.push, and we will push e, the remaining quote there. Okay, so we want also to form or to define another mutable string s2 equaling to an empty string .2. Okay, and you want to push something to s2.push, and this would be e, but there is an e that I would really want. Let me see. Yes, it's this engraved E. I was trying out this. Okay, so I am pushing this engraved or accented E, and we will see why that. And we also form E3, and we are pushing the perfect, the pound sign. So what we have ASCII characters here, the E, but we have, what happened? Okay. Yes, and I think I didn't save. Yes. So we have the ASCII character and this engraved or accented E and this pound sign. So basically we want to see what happens. So I was trying out that. So if I call the Rust compiler and I call it again, I call the byte file formed, which is the string structure. Okay, we are not printing out something. We forgot that. So I need to print ln, print a macro, and basically I want to print the size s1 dot capacity and s1 dot length. Yes, so I will need to do this for s1 and s2. I'll just copy that. So with this s2, s1, why is it saying s1? I'll need to change that here, s1, and this is s3. Okay, so if we print, we do this again, we are saying that the size or the capacity of string s1 is 8 and the length is 1, which is expected because it is one element that we have pushed to this string s1. But when it comes to string s2, we have allocated 8 bytes as the size, and the character is showing us that the length is 2, yet we have one character. Why is that? Now, the reason why that is because of the compiler implementation, but most importantly the ASCII characters difference and this engraved or the grave E character itself, because it's not an ASCII character. So we know that in our compiler we follow the UTF-8 notation, and in the UTF-8 notation, every character is represented by 1 byte mostly. There could be cases where you have more than one, but depending on the character, 1 byte is assigned for each character. Now, for this character, the engraved the accented E, it is assigned 2 bytes according to the compiler design. So that's why its length is 2. So mainly that's the reason why you're seeing that the length keeps growing like that. But we want to test out something. What would happen when several characters are added to dynamic string one at a time? When several characters are added to a dynamic string one at a time. If you know how a vector is implemented, you really see where we are going. That vectors, they keep growing, like they are flexible, and they can handle data depending on what is coming in. They can shrink and they can expand. So if we have that dynamic string st, and we try to dynamically put in something for I in 0.10, I might not even need that I, so I might put a dash there. So what we want is basically we want to insert something dynamically at every iteration. So we want to print ln, and we want to print what we are inserting in. We are inserting in the capacity at when I is 0 or at the first iteration, and we want to push in something. So let us push s dot push, yes, that push a. But we are missing out something. We want to see the characters being added, and we want to look at the memory that is being allocated at every step. So in order to do that, there is this print formatter that is, we've looked at this in our videos on this channel. We want to print out the address mainly, and in order to do that, we write s dot as pointer, and it is a method, so on the string, so we put the curly braces. So we do that, and we push to the string. Now eventually we want to print out the entire string that has been created, and I don't want that, I don't want this. I want capacity and length, and I want s being printed. So this should be okay, maybe I need it, and I need s. After all, I need that memory of the last sort of like element. So it might be like the 11th element, which in this case will appear as the 10th. So I need its address too, and that means I will need something here also. So basically, I want to see how dynamic a dynamic string is, just like how vectors can behave. I hope that makes sense. So we try to print again, to run the file, sorry, rust c string. We are getting problems, and here we expect a comma. I guess that's the problem. Okay, again. What's the real expected a comma or an operator and a structure on line 24. Oh, okay, even here. My bad. Okay, now it's fine. And when we call the created file, yes, voila. This is what I wanted. So we can see that for the iteration, when the iteration was 0, we are seeing that the size is 0 and the capacity is 0 and the length is 0. And that makes sense because nothing has been pushed there. But as soon as the element we reach the first and we start pushing, we are seeing that the allocated size is 8 bytes, okay? And the length keeps growing up to the 8th. Now, the address, we can see that the address that is being allocated is almost the same. Actually, it remains constant. But we see that as the size reaches 8, the length 8, that means that string can no longer hold 8 characters or 8 bytes being allocated. And remember I said that in vectors, in Rust, strings behave as vectors and they behave as vectors of bytes. So 8 bytes assigned, and that means you need to allocate more size. So more size is allocated and the length keeps growing. So this is how dynamic strings behave, and they're implemented underneath as vectors. And we are seeing that this resultant string at the end of the day that we print out here is here, and you can see the characters that are there. So that's what I wanted to show you guys, that strings are very powerful, but they are also dynamic in Rust, and they are dynamic like vectors, because in memory they keep expanding, and depending on the size that we need, more space is allocated. So thanks for watching, and see you guys in the next video. Bye bye.